Dear students, in first module, we can cover data structure concept, array operations, array implementation, etc. Now we will study stack and queues. There are two linear data structures. Okay, first we can the linear list and arrays allow one to insert and delete elements at any place in the list, at the beginning, at the end, or in the middle. But there are certain situations in computer science when one wants to restrict insertions and deletions so that they can take place only at the beginning or end of the list, not in the middle. In such situations, we can use two concepts, stacks and queues. Okay. Then, what do you mean by stack? A stack is a linear data structure in which items may be added or removed only at one end. Okay, by linear data structure, that means linear, the elements in stacks are arranged in sequential order. A stack is a homogeneous collection of items of any one type arranged linearly with access at one end only called top. That's an important point. Top of stack is very important. Formerly, this type of stack is called last in first out stack. That's LIFO. That means LIFO, last in first out. Whatever an element inserted into the stack last, that should be removed first. Okay. Then there are two operations in stack, push and pop. Data is added to the stack using the push operation and removed using the pop operation. The next we can see some of examples. When the plates are being stacked, they are added one top of each other. Similarly, when a plate is taken, it's usually taken from the top of the stack. In the figure, we can see stack of plates, then stack of books, then box of tennis balls close at one end. That's a point. Then stack of rings, then stack of chairs. So, we can say stacks are also known as push down list. Then, this is a representation of stack, pushing the element and popping the element from the stack. Then we can see the top of the stack. Then we can discuss the operations on stack. There are two operations, push and pop. Push operation means insertion, then pop means deletion. Okay. Suppose we can consider 5 elements A, B, C, D and E. Then we can perform the push operation. First we can insert an element A, then insert B, then C, D and E. Okay. Then top of the element can be changed each time. First A can be inserted, then top is A. Then next B can be inserted, then the stack of top can be changed, that B position, that's the second position. Then the third element can be inserted, C. Then the top of the stack can be changed. The next D inserted, then top can be changed to fourth position. Last, the fifth element can be inserted, then the top can also be changed. Okay. Then we can perform the pop operation. This pop operation can be in the reverse order. First, the representation A, B, C, D and E. Then top element is E. The next we can pop one element from the stack. Then top can be changed to fourth position, that's D. Okay. Each time the top element can be changed one by one. The next we can discuss the array representation of stack. Stacks may be represented in computer in various ways, usually by means of a one-way list or a linear array. Okay. We will study the array representation, then the operations, how to implement, etc. Stack can be maintained by a linear array stack, a variable top which contains the location of the top element of the stack and the variable n which gives the maximum number of elements that can be held by the stack. Then first we can check the condition if top equal to 0 or top equal to null. That means the stack is empty. Okay. Then first we have an algorithm for insertion. Then that's operation is push. Then we can use the elements stack, top, n and item. Stack is the name of stack. Then top is the top of the stack. N is the size of the stack and item is the new item to be inserted into the stack. Then we will see this procedure pushes an item onto the top of the stack. N is the size of the stack. Then stack is the name of the stack. Then we can follow the steps. First we have to check already the stack is filled or not. Okay. If then we can use the condition is if top equal to n, then print overflow and return. Okay, that means the stack is full. We cannot insert an item into the stack. Otherwise, that means top not equal to n, we can set the value top equal to top plus 1. That increase the top by 1. The next we can insert an item to that position, that is stack of top equal to item. Insert item in new top position. Okay, this is the procedure for inserting an element into the stack. We can then next we can see the deletion algorithm. That's a pop operation. Pop, then stack, top, item. These are the array elements. This procedure deletes the top elements of stack and assign it to the variable item. Okay. Then in this situation, we first check whether if and any item to be deleted, an item in present in the stack. That means if top equal to 0, then an underflow condition occurs. That means the stack contains no elements. So first we check if top equal to 0, then underflow occurs. Otherwise, if top not equal to 0, set item equal to stack of top. That means then item is the variable and the stack of top element to be assigned to item variable. Then set top equal to top minus 1. Decrease the value of top by 1. Okay. The next we discuss application of stack. Okay. We know arithmetic expression. Let Q be an arithmetic expression involving constants and operations. The binary operations performed on Q are addition, subtraction, multiplication, division and exponentiation. Then we can consider the level of precedence of operators. We can see highest precedence operator is exponentiation, the next highest multiplication and division, and the next is lowest precedence operators addition and subtraction. In case of parenthesis, we can check left to right order. Okay. The next, there are three types of notations used: infix notation, postfix notation, then prefix notation. Okay. Then what do you mean by Polish notation? Okay. For most common arithmetic operations, the operator symbol is placed between its two operands. That means operand, then operator, then operand. Okay, this is called infix notation. For example, a plus b, c minus d, then e star f, g by f, etc. Okay, this is the example of infix notation. The next, if the parenthesis is present, that will be evaluated first. That example is a plus b star c. Here, first calculate a plus b and then multiply it with a c. Okay. If the operator symbol is placed before two operands, it is called prefix notation. Okay. That plus then a then b. That means the prefix of notation. It's also called Polish notation. Okay. Not, for example, plus AB, then minus CD, then star EF, etc. If the operator symbol is placed after its two operands, then this type of notation is known as postfix notation. Okay. or suffix notation. That the example is AB plus CD minus or EF star, etc. Okay. In this situation, in computer, usually evaluates the arithmetic expression written in infix notation in two steps. Okay. First, convert the infix expression to postfix and then evaluate the postfix expression. Then we will see the conversion, infix to postfix conversion. The algorithm for converting infix to postfix is given below. Postfix QP. Okay, Q is the infix notation and P is the postfix notation. Suppose Q is an arithmetic expression written in infix notation. This algorithm finds the equivalent postfix expression P. Okay, then first we start step 1. Push left parenthesis onto the stack and add right parenthesis to the end of Q. Okay, then we can consider one example. Here is a infix expression A plus B star C. To its corresponding postfix expression, we can convert it to postfix form. First we can start with the step 1. Q is equal to, Q is an arithmetic expression written in infix notation. Okay. Then A plus B star C. Okay. First we can insert a left parenthesis onto the stack. We will see the operator stack, input character, then operator stack, then postfix expression P. Okay. In the table we can see, then for, at step 1, a right parenthesis can be inserted at the end of Q. Here A plus B star C, then a right parenthesis can be inserted at the end of Q or infix expression. Then return to algorithm. Step 2, scan Q from left to right and repeat step 3 to 6 for each element of Q until the stack is empty. Okay. But first we can go to the step 3. If an operand is encountered, it can be added to P. Otherwise, if a left parenthesis is encountered, push it into the stack. Then we will see first in the example. First we can insert a left parenthesis onto the stack, operator stack. Then we can scan Q from left to right. First we can see a left parenthesis that can also be inserted into the operator stack. Then next A is an operand. So if an operand is encountered, then it can be push it into the postfix expression P. Okay. Then return to the algorithm. If a left parenthesis is encountered, push it onto the stack. If an operator OP is encountered, okay, then next an operator is encountered, plus operator, then this operator can be encountered. We can do two things. First one, repeatedly pop from stack and add to P each operator which has the same precedence or higher precedence than operator. Here we can check the operator has the higher precedence or the same precedence. Then add operator to the stack. Here the operator is plus. This plus can be inserted into the operator stack. Okay. Then next in the example, other operand is encountered B. Okay. Then if an operand is encountered, this operand can be push it into the postfix expression. Then postfix expression contains A, B. The next algorithm step 5, if an operator. Then next step 6, if a right parenthesis is encountered, then repeatedly pop from stack and add to P each operator until a left parenthesis is encountered. Okay, then remove the left parenthesis. Here a right parenthesis, in this example a right parenthesis is encountered. So we can pop the plus operator from the stack and push it into the postfix expression. Then AB plus. Okay, Then next here we can also remove the left parenthesis also. Then next the operator multiplication. Okay, multiplication operator is encountered. Then it can be pushed into the stack. There is no change in the postfix expression. Then next C is encountered. C is an operand. Then this operand can be inserted into the postfix expression A, B plus then C can be encountered. Okay. A right parenthesis is also encountered here. Then we can pop star from the operator stack and push it into the postfix expression or add it into the postfix expression P. Then A, B plus C star. This is the procedure for converting infix expression to postfix expression. Okay, in the algorithm, if a right parenthesis is encountered, then repeatedly pop from stack, add to P each operator until a left parenthesis is encountered. If a left parenthesis is encountered, then that left parenthesis is also removed from the operator stack. Okay, this is the procedure for converting infix to postfix expression. Then in the previous first we convert the infix expression to its corresponding postfix notation, then it evaluates the postfix expression. Okay, then we have to evaluate the postfix expression. The evaluation of postfix expression involves the following 4 rules. Okay, first one, find the leftmost operator in the expression. Select the 2 operands immediately to the left of the operator found. Then third one, perform the indicated operation. Replace the operator and operands with the result. Okay, these are the main 4 rules. Then we can go to the algorithm postfix evaluation. Here one by one. Step 1, add a right parenthesis at the end of P. That means here is an example. Evaluate the following postfix expression using stack concept. Okay, the elements are 8, 5, 3 plus 9, then star plus 4, then plus. Here P is equal to, P is the postfix notation, then P is equal to 8, 5, 3 plus 9 star plus 4, then plus. By using step 1, we can insert a right parenthesis onto the postfix expression P. Okay, then step 2, scan P from left to right and repeat step 3 and 4 each element of P until the right parenthesis is encountered. Then first we have to scan P from left to right. Here is the example. Then the first element in the postfix notation is 8. Okay. Then go to step 3. If an operand is encountered, push it onto the stack. Okay. If an operator is encountered, then remove the 2 top elements of stack where A is the top element and B is the next top element. Okay. In this example, 8 is an operand. Okay, then the 8 can be added to the stack. Then 5 is also an operand. Then 5 is also added to the stack. Then 3 is operand. Then 3 is also added to the stack. Then the stack contains 3 elements 8, 5 and 3. Then one operator is encountered. Then if an operator is encountered, operator OP is encountered, then remove the 2 top elements of stack. Then first we can remove the first 2 top elements. They are 5 and 3. Then A and B, by using the A and B representation in a algorithm, that's A is the top element and B is the next top element. Here in this example, 3 is the top element and 5 is the next top element and perform the operation. That means 5 plus 3. Okay, then the result can be returned back to the stack. That's 8, 8. Okay. Then in these steps, evaluate B operator A. This is an important point. A is the top element, then B is the next top element. The calculation can be performed always B operator then A. Okay. Then place the result place the result of B back onto the stack. Okay. Then set the value equal to the top element on stack. This is the procedure for evaluating the postfix expression. Here in this example, first first operator is the plus, then 9 is the operand. Here 9 can be added to the stack, then the stack elements are 8, 8 and 9. Then a star operator is encountered. If an operator is encountered, we can pop the two top elements from the stack and perform the operation. Then here 8 and 9 are the two top elements. Then we can perform the multiplication operation. Then we can get the result 8 into 9, 72. Then the result can be added to the stack. Okay. Then next a plus operator can be encountered. Okay. Then plus operator add the two top elements. The top elements are 8 and 72. Then perform 8 plus 72, that the result is 80. Okay, then this 80 can be added to the stack. The next one plus operator can the next one 4 is an operand. This can be added to the stack. Then the stack contains 80 and 4. Then one plus operator is encountered. Then we can perform the addition. Pop the two top elements, that are 80 and 4. Then we can perform the addition. 80 plus 4 is equal to 84. Okay. Then next is the right parenthesis. Then the postfix evaluation can be entered. That's the last step. If first we in the algorithm step 2, we can say scan P from left to right and repeat step 3 and 4 for each element of P until a right parenthesis is encountered. Here the right parenthesis is encountered, the postfix evaluation is completed, then the result can be obtained 84. This value can be added to the stack. This is the final result of the postfix expression 853 plus 9 star plus 4 then plus. Okay. This is the one of the application in fix to postfix conversion, then postfix evaluation. Then next we can discuss about Q. Q is also a linear data structure. That means linear means the elements in the queue are arranged in sequential order. Okay. First, here we can see a figure, person leaving the queue, person entering the queue. Okay. A queue is a linear list of elements in which deletions can take place only at one end called the front and insertion can take place only at one end called the rear. Okay, here two ends are exist, that's front and rear. In the case of stack, it has only one end, that's the top of the stack. Insertion and deletion can take place only at one end called the top of the stack. But in the case of queue, here we can two values, front value and rear value. Here insertion can take place at rear and deletion from the front end. Okay. Queues are also called first in first out list. This can follow the first in first out strategy. That means the elements inserted into the queue will be first element to be removed. Okay. Then some of the real life examples of queue are a queue of people at ticket window. The person who comes first gets the ticket first. The person who is coming last is getting the ticket last. Okay. This can follow the first in first out strategy. The next one is the luggage checking machine. Luggage checking machine checks the luggage first that comes first. Therefore, it follows the first in first out mechanism. Then another example is patients waiting outside the doctor's clinic. The patients who comes first visit the doctors first and the patients who comes last visit the doctors at last. Okay, so there it follows the first in first out strategy of a queue. The next, the representation of queues. Queues may be represented in various ways by means of one-way list or linear arrays. Then it contains the elements queue, then a variable friend, then rear. Okay, first we have to check the condition. Friend equal to null. That means the queue is empty. Okay. Then next here is the representation. The queue contains three elements A, B and C. Then the value of friend equal to 1 and rear equal to 3. That means the elements can be inserted in rear and the elements can be deleted from the front end. Okay. Then the value of friend is 1, the value of rear is 3. Then the detailed representation of queue is given below. Then in figure A, the queue is empty. Okay, then the value of friend equal to 0, then rear equal to 0. The queue is empty, so there is no elements in the queue. The next figure B, we can insert one element, that's A. Then the value of friend and rear can be changed. Friend equal to 1, then rear equal to 1. This means the queue contains only one element. Okay. Then next in figure C, we can insert the second element B into the queue. Then the value change, the friend value cannot be changed, that's friend equal to 1, and the rear value can be changed, rear equal to 2. Okay. Then next in figure D, we can insert the third element C. Then the value can be changed, rear value can be changed, that's 3. Then next in figure E, not the point, in deletion. Okay, the first element can be deleted, that from the front end. Okay, insertion can take place at rear and deletion can take place at the front end. Then the element A can be deleted from the queue. Then the value of friend can be changed, that's 2. That means if an element to be deleted from the queue, the value of rear can be incremented by 1, friend equal to 2, then rear equal to 3. Then figure F, we can insert the next element D. Then then the value of rear can be changed, that's 4. Then value of friend is equal to 2. Okay. Then next okay, then we can see an algorithm for inserting element into the queue. Then queue insert. This array contains queue, n, item, friend and rear. Okay. Then n is the size of the queue, item is the item to be inserted into the queue, then friend is the friend element, then rear is the rear element. That's the position of the friend and rear. Then next we can follow the algorithm. If step 1, first we can check if rear equal to n. Rear equal to n, that means overflow occurs, that the queue is full, then we cannot insert an element into the queue. Okay, then if rear not equal to n, we can set rear equal to rear plus 1. We can increment the value of rear by 1, then item can be inserted into that position, queue of rear equal to item. Okay, then in this insertion we can first check if rear equal to n, that means the queue is already filled, then we cannot insert a value to the queue. Then next is the next we can discuss the deletion algorithm. Here first we check, from the deletion first we check if friend equal to 0. That means friend equal to 0 if no items present in the queue, then we can occurs the underflow condition. Then if not friend equal to 0, we can insert element into the queue. Then set item equal to queue of friend. Then set friend equal to friend plus 1. That means first we can item equal to queue of friend means that position element can be assigned to the variable item. Then we can add the value. They can increment the value of friend by 1. That's a friend equal to friend plus 1. In this deletion algorithm, first we have to check if friend equal to 0. Then there is no element present in the queue. Okay, this is the condition. Then next, linear queue has some limitations. Okay, we consider example. Consider a queue with the size 4. Initially, the queue is empty. Figure A, the initially queue is empty. Then the value of friend equal to 0. Then array equal to 0. In figure B, we can insert 3 elements A, B, and C. That's a then the value can be changed friend equal to 1. Then array equal to 3. Okay. In the next step, figure C, we can delete 2 elements from the queue A and B. Then the value of friend can be changed friend equal to 3. Then rare is also 3. That means if friend equal to 3, then rare equal to 3. That means the queue contains only one element, that's a C. Then in figure D, we can insert the element D. Okay. Then change the value of rare equal to 4. Then when we try to insert another element E, then an overflow condition occurs. That's a point. If we have already 2 space available, but we cannot insert the item E into the queue. This is the limitation. Okay. Then in a linear queue, the traversal through the queue is possibly only once. That's the point. Only once the queue traversal is possible. That is one an element is deleted, we cannot insert another element in its position. This is a disadvantage of linear queue. Okay, this disadvantage of linear queue is overcome by a circular queue, thus saving memory. Okay, we can discuss circular queue operations in the next class and its operations, its implementation, etc. Then, okay, thank you.